Hello everyone, my name is Saprit Saini and today I will be presenting my project AI-powered garbage taking robot using Raspberry Pi 5 and Arduino Nano IoT. This project demonstrates how embedded system can be integrated to create an intelligent autonomous robot that contributes to cleaner and smarter cities. The problem inefficient waste management. We all know that the waste management in most communities still relies heavily on human labor. This often leads to overflowing bins, unhygienic conditions, and health risks for workers. Smart bins exist in some advanced cities, but they are too expensive and complex for small societies or universities. That's why we need an affordable, autonomous robot that can collect garbage and make waste management more efficient. uh, Current solutions limitation gaps. Existing solutions either use expensive robotic arms or stationary smart bins with sensors. These are not scalable, adaptive, or cost-effective for smaller environments. So I wanted to bridge that gap by designing something simple, affordable, and automated, something that can move, detect obstacles, or interact with humans and make garbage collecting an engaging activity. Opportunity and autonomous affordable solution. In 2025, AI is being integrated into almost every device. The environment is in something that benefits our environment. I thought it would be great if a small robot could move around, detect humans, and avoid obstacles, talk politely to the people around him, and encourage them to throw garbage responsibly. Turning a dull activity into an interactive one, this idea became the foundation of my AI values robot project. The our proposed solution, the AI values. The system overview. My system consists of two main brains, the Raspberry Pi 5 and Arduino and IoT. And wait, yes, the Raspberry Pi 5 handles AI vision and user interaction using a camera, microphone, and Bluetooth speaker. The Arduino IoT handles real-time control. It manages the motor, sensor, and LEDs. Both are connected through UART, serial communication, allowing them to share data efficiently. The robot is powered by a 12-2500 mAh lithium-ion battery and build on a custom 3D printed assembly body. Key components. 4 DC motors provide motion through an L2 magnet and motor driver, which controls speed and direction via PWM signals. 4 autonomous sensors, 3 in the front and 1 at the rear, detects obstacles and help the robot navigate safely. White and red LEDs act as a user indicator. White when the path is clear and red when an obstacle is detected. Uh, Raspberry Pi 5 camera module enables human interaction. Microphone and Bluetooth speaker hosts voice-based interaction. And I will also add two switches, one to power the robot and another to keep the Arduino powered while uploading code wirelessly. So it will be an ease. Communication protocols. The Raspberry Pi communicates with the Arduino through UART, transmitting data at 3.3 volt logic. The Arduino reads autonomous data and makes decision and drive the motor accordingly through the L298N module. Each side of the motor driver ENA and ENB is connected to PWM pins D5 and D6 for precise speed control, while IN1 to IN4 control direction. This makes the robot capable of forward, reverse, left, and right, and even it can spin 360 degrees. Okay, this flowchart shows how my garbage picking robot works. First, the system starts and set up communication between the Raspberry Pi and Arduino. Then the camera and ultrasonic sensors scan the surrounding. If any obstacle is detected, the robot avoids by turning left or right. If the path is clear, it continues moving forward. When garbage is detected, it turns on an LED light and waits for the user to drop it in the bin. After collecting the garbage, it keeps patrolling again until a manual stop command is given. Future enhancement. The next stage of this project will include integrating AI on the Raspberry Pi, so the robot can recognize humans and humans. using the five camera and politely request them to dispose of garbage. This LED of the bin will open automatically using a servo motor. It can also be connected to IoT platform to monitor battery distance covered and user statistics. Conclusion. To conclude, this figure shows how powerful embedded systems like Raspberry Pi and Arduino can be when combined effectively. It is a scalable, affordable, and designed with simplicity. It tackles a real-world issues with creativity. In the future, such robots can be used in schools, offices, and public spaces to promote cleaner surroundings and reduce human workload. Thank you so much.